I used breast cancer data. Actually, uh, you people don't need any data. I gave some code to download the data also. Just we'll restart. Okay, I restarted Kernel also. Let's say I have taken breast cancer data for this PCA. This is the we have this data set in sklearn package, so you can directly download this data from sklearn datasets. In the data we have the 569 records but 31 features. Out of the 31 features, one feature is the feature. Target feature means dependent variable. 30 are independent variables. These are the sum. This is the dependent variable target, and these are the independent variables, means we are using these variables as a input to build model. Okay, let's see what is the whether it is a classification problem or regression problem. You already know the difference between the classification and regression. Whether the output is continuous numeric data, it is the regression model. Whether the output is a discrete categorical data, then we'll use classification model. So this is the classification model. It have the 0, 1, two
Don't
classes.
have
That is
discrete
the
values.
binary classification. What?
We don't have discrete values like it's a
0
continuous
and
type
1.
of
This is a
data.
continuous. It's not a continuous data. It is the 0, 1. There is the two categories. This is the categorical data, Ranjit. Let's see. There are the two categories. It's not a continuous data. Continuous data means, for example, age, price, sales, salary. These are comes under continuous data. Is it?
Yes, ma'am.
Yeah.
Some
Here we here we have the two classes in our target data, 0 and 1. So it is the categorical data. Continuous data means which is measurable. For example, if we have the two data points, the difference between the two data points is measurable. Whether it is measurable, it is the continuous data. Whether it is not measurable, it's a discrete categorical data. For example, under movie rating, don't take movie rating, it's a ordinal categorical data. Let's consider the maths, physics, same example, subjects. If we directly don't use maths string, which is the text, maths, physics, to build a model, what we do, we'll convert that data to the we'll assign 0 to the maths, 1 to the physics, 2 to the social, 3 to the Hindi, like that. But the difference between 2 and 4, that is the normally it is the 2. But in this scenario, there is no difference between the 2 and 4. Why? Because 2 is physics, 4 is the Hindi. Is there any measurable distance between the physics, Hindi, science? Shall we able to
no.
measure which subject is important, which subject is not important? So we can't measure like that. That's why we call that is the categorical data. Here a 0, 1 means this is a breast cancer diagnosis. Whether it is 0, that means no cancer. Whether
Ma'am,
it is
zero
1,
one in the sense like they are same as a boolean values, true or false.
yes, true or false. That's it.
Okay, fine. Zero
That's
one.
why, yes. That's why
Not
it is the categorical data. That's why it is a classification. We'll use mostly classification for this categorical data.
okay.
Yeah. Let's see. I already explain you how to build logistic regression, linear regression. So before going to use PCA, first I want to check how is data and how much accuracy it's providing without doing any data preprocessing. Okay, that's why I have directly taken independent variable and dependent variable. I have split it with 0.3 ratio. That means 70% is the training data, 30% is the test data. I run the logic. It gives the 90% accuracy. Okay, it gives the 90% accuracy without any
Ma'am, how
data
to increase
preprocessing.
the accuracy at this moment?
Just a minute.
How to increase the accuracy? Like if we decrease the test size, accuracy will be increasing.
No, that's what. That's why you need to know about that difference. That's why first I gave you here. I did not do any data processing. I did not reduce any features. I did not reduce any records also.
Yes,
I
ma'am.
used
Yeah.
I used entire data what they are provided.
Yeah.
Yeah, I assigned -1 means here I am removing dependent variable, that is the target variable for the y, because x is the input, that is the independent variables. Here I provided only target variable for the y, that means that this is the dependent variable. Then after I split into the train test, then after I build logistic regression model, I give this x train and y train to the logistic regression. Then after I I calculated some score, what is the accuracy on the test data, x test, y test. It provides the 0.91 accuracy. That is the 91% accuracy. Let's go for the another problem. Here we'll use correlation. For example, I am assigning target variable to the diagnosis. Why? Because this is the diagnosis data, breast cancer diagnosis data. Let's see. Here I calculated correlation between the diagnosis to the all independent variable. Okay, these are the 30 independent variables I calculate. For example, let's say target diagnosis, both are same. Why? Because I assigned this target column to the diagnosis column. That's why correlation between the diagnosis and target is the 1. So it's both are highly correlated. See, let's check. Let's see. Here, this is the function to sort the ascending or descending way the results. For example, here I provided false to the ascending. That means I want to sort values in descending order. That's why the correlation values sorted based on the descending order. Let's see how many variables correlated more than 50%. These are the some variables correlated to the dependent variable more than 50%. Okay.
Yes, ma'am.
Like this, you
Like
can
these are the
select.
factors.
Yeah, these are the highly correlated with the target variable. These are the some independent variables highly correlated. By that means these independent variables have the high information about the dependent variable. If you
Yeah.
want to classify whether it is true or false, that information. For example, let's see here to here, these 4 or 5 variables have the 50% information, 50
Yeah.
to 60%. But this one, these are
70 to
have the
80%.
yes 70 to 80% information about the dependent variable. So first I am taking only 60%, more than 60% correlated variables like this. These are the some variables which are highly correlated more than 60%. That means these independent variables have the 60% information about the dependent variable. Okay. Here I am introducing one thing, a variance inflation factor is a measure of amount of multicollinearity. Multicollinearity means, let's see, here we have the uh, 5 and 5, 10 independent variables. So here out of 30, we selected 10 independent variables which are highly correlated with the dependent variable. But in these 10 variables, there is a chance to be 2 or more variables have the same information. For example, let's take mm, perimeter and radius. Okay, perimeter and radius. Is it?
Yes, ma'am.
Yeah. Maybe these two will provide same information about the dependent variable. Why? Because let's take an
But
example of circuit.
ma'am, one doubt.
Yeah.
Ma'am, worst radius and worst perimeter, they might give the same information, but mean parameter and worst parameter, how they will be related basically.
Yeah, maybe there is a chance. That's what I am saying is, for example, let's take worst perimeter and radius. If we have the radius, we don't need perimeter.
Yeah.
Radius, we are able to get perimeter by using the radius value.
Yeah, we can get it. Yeah.
So instead of using this radius and perimeter, it's better to use one thing.
Yeah. We
Yeah,
can remove one
but
other thing.
yeah, but by seeing radius perimeter, we are all mathematical students. Due to that, we are able to say these two have the same information. But some other independent variables, based on the name, we can't say like that.
Yeah.
So this is the VIF is the one tool, one library. It provides this multicollinearity. which are independent variables, which are have the same information. For example, which are have the same information about the dependent variable. We call, if more than two variables have the same information, we call it is the multicollinearity in regression analysis. So, if multicollinearity exists when there is a correlation between multiple independent variables in a multiple regression model, this can adversely affect the regression results. Same thing, if we are using more variables which are having the same information, it's not useful the model. Why? Because all of them are giving same information. Why should we need to inquire all of them? It's better to inquire one of them. It saves the time. It becomes a low performance. It becomes a very simple thing, right? That's why this VIF will provide us that information. VIF and
Like
tolerance.
the major function is like it will be removing the like it will be eliminating the unuseful information.
Yes,
Okay.
you can't say unuseful information, redundant information. There is some difference between the unuseful and redundant. For example, let's take this one, ID, application ID, server ID, unique ID, employee ID. This is the unique thing. It
Yeah.
is the unuseful data. In some point of view, time also unuseful data to predict the house price,
Yes.
everything. Yeah, this is the unuseful. Redundant data means two or more variables have the same information. That is the repetition, duplication. So, that type of redundant information, if we want to eliminate that type of redundant information, this will be useful. It will be useful for the avoid unwanted data and redundant data. Just it's not a major thing, Ranjit, but you need to know about the what is the different types of data: unwanted data, useful data, structured data, redundant data. Just you need to, if you know the difference between that one, the terminology. If you know the terminology, difference between those terminology, it is easy to use some libraries techniques also.
Yes, ma'am.
Yeah. For example, some techniques, for example, this VIF useful for to avoid the redundant data. If you feel, so for example, if you got the less accuracy, you need to think in different ways. If you know the terminology redundant and unwanted, some other multi-dimensionality reduction, you will try all techniques one by one. Which technique gives high accuracy for this data, you will finalize that technique or that model is the final model I build it to to predict this one, to predict this information. Okay, that's why I want to say these many terminologies. Okay, this is the way. Now you are able to understand why we are calculating this variance inflation factor. Why? Because to measure the amount of multicollinearity in regression analysis. Okay, let's see. It provides the some VIF value for the each and every variable, each and every independent variable. Let's see. Uh, that means, for example, let's take target have the three. That means it have the very less multicollinearity, but mean perimeter and mean radius, these two have the high VIF value. That means high multicollinearity. Okay. So I am selected. I have taken it as the 5 as the threshold value. These are the some features. For example, I think 15 or 50. Mean radius. Let's take there is the 3 points: worst, converse points, and worst perimeter. Out of these, I have selected one thing, and out of the mean radius, mean perimeter, and out of all these mean area, I have take one thing, that is the which one have the high multicollinearity. So that is the mean radius. Another one is the mean concavity. Where is mean concavity? This one. Okay, let's just a minute. These are have the less than 3 VF value. Okay,
Ma'am, above one,
previously what?
what's the difference between above and the below one?
Here the multicollinearity is very high.
Yeah.
204, 35, 425. but I want to take less than 5. That means multicollinear. There is no collinearity between the one independent variable and another one independent variable. For example, let's take, we want to predict same house price, location, it have the some information, and square feet area, it has the some information. But location will explain 80% about the price. At the same time, square feet also explains 80% of the i- price value. But there is no linearity. There is no relationship between the square feet value and location value. Is there any relationship between the square feet and location? This is the related to the area. This is the related to the region. That's what I want here. Previously, let's take, I have taken mean radius. Previously, we already discussed, if we have the mean radius value, we can able to calculate mean area, mean perimeter. Is it
Yes.
right?
Yes, ma'am.
Yeah, that's why I have selected mean radius. Out of these three, I have selected one value.
Yes,
These
ma'am.
three are highly correlated. Let's take this one. Out of these, I have taken which one is better. If
Me-
we have the radius, it's better to calculate a perimeter, area, or any side, everything. If we have taken area, we need to first calculate radius. Then after we are able to calculate perimeter or anything.
Okay, ma'am. Got it,
That's
ma'am. Like
yeah.
in three things, we are selecting the highest one.
Ah
Based,
yes, which have the highest information.
yeah, sure.
Yeah, that's why
So
I have selected these three, and I have calculated VIF value also. See, VIF multi-collinearity. The collinearity between these three data points is very less. 4, 2, 3. Previously, it is the hundred, thousands,
ma'am,
30,
how
40,
it,
like this.
like again we if we are doing like now it's decreasing.
Yes, if
Okay, ma'am.
it depends on the which type of independent variables we are selecting. It depends on that.
Before we have selected like like nearly 10. Now we are
Yes.
selecting only three.
Let's take for example. Here I selected based on these three, based on the tolerance.
Yeah,
Which
ma'am.
are have the less tolerance? Let's take mean radius, mean area, mean perimeter. Compared to these three, this one have the less tolerance. Mean radius. This is the 0.000622. It's the 0.04. Let's take this one is the 0.656. Compared to 656, 622 is the lesser value. So based on this tolerance, I have selected some variables. Those are the three variables. Okay. I have again calculated what is the multi-collinearity between these three variables. These are very, very less. Okay.
Yes,
So
ma'am.
we selected these problems. Then after, I again tried to build model by using these three variables. These three independent variables. See, features. What are the features? These three variables. I am providing these features to the input value. Okay.
Okay, ma'am.
I got the 84%. So
One.
this VAF is not working for me. Why? Because if I use entire models, 30 features, it gives the 91% accuracy. If I give three features, it gives the 84% accuracy.
Yes, ma'am.
What is the difference? 7%.
Yeah.
But you can think one way. If they want only simple model, they want a high performance wise, uh, they will able to tolerate nanoseconds only to predict whenever new data point comes, they want to, they are expecting results within nanoseconds.
Yes, ma'am.
Okay, let's see. Here we are giving only three variables to train the model, so it is very simple model. So whenever new point comes, it will predict within nanoseconds. But in in our first model, here we used entire 30 features. 3 to 30 means 10 times. Okay, if we use these 30 models, it gives a 90% accuracy, but it won't predict within nanoseconds. Maybe
Like it
it
will
will
be
take milliseconds.
like as it's a huge amount of data which we are like which we are
Yes,
doing. it might
Yes.
take time.
Yes, time. Not only time, it will take to try time to train the model.
Based on, as we are having 30 independent ways, it might take time basically.
Yes, to build the model. That's what we
That's the reason we are using only 3 here.
based on the customer requirement. If instead of time, if he give priority for the accuracy, then they will tolerate some delay. At that time, we need to build model by using 30 independent variables, or we
Like
need to check
like
other.
ma'am, if uh, client is okay with the milliseconds time, so that we can go with the 30 data.
Yes, but instead of going 30 amount, if till now we tried to um, eliminate the which are multicollinearly highly multicollinear independent variables. We have the another method, that is the reduced features, that is the PCA, principal component analysis. Okay, so I want to reduce features. I want to build model on less data. It will satisfy the both performance and accuracy. First, we need to try for that. We need to try to satisfy client with performance and accuracy also. If it's not possible to satisfy in both ways, then we need to tolerate by decreasing one thing, we will try to increase another thing.
Ma'am, one thing, if in BIF we get the accuracy around, as we have got before, as 91%,
Mm.
if we get accuracy of 95 to 96% in the VIF, so that we can continue with that, right?
Yes, definitely.
Oh, if it is not working VIF, we are going for the PCA,
PCA. If it's not working for PCA, we will go for the another method.
like another model we will use.
Yes, but we don't know based on the case, based on the data, which model, which technique will be useful. Which by seeing case, by seeing data, we can't say that one. We need to go with all methods, all techniques. While trying this type of analysis, we will get some knowledge about that data. Yes, this data doesn't have any multicollinearity. That's why it's not gives that much accuracy on the VIF. So we need to think other way. Based on that knowledge, while building lot of models, we will definitely get that knowledge. How to select data pre-processing and dimensionality reduction techniques or regression models. Which one gives good results for this scenario and this data? We will get that knowledge if we build lot of models by using lot of data sets, lot of techniques. That's why I suggest you people, please try to build models by using TensorFlow and Keras and other things also. Some you can use some BERT models which are already pre-trained models. You can try to fine tune those pre-trained model. First, you can check by using directly pre-trained model how much accuracy you are getting. Then after, you can try to fine tune that model with the existing data what we already have. Then after, you can again check that model whether it is increased to the pre-trained model or not. So why? Because pre-trained models, they will provide that model for the global services. But in our case, we need to we don't need all other cases. We need some particular case, particular expected output. So you need to fine tune that model, but you don't have that much data. For example, object detection. If we want to detect objects in an image, I want to provide images for the each and every object. For example, you are trying to build model to classify to detect the objects of the animals. Are you able to provide all images related to the all animals? Not only images, uh, animal position also, by sitting, by standing, by siding, by flipping.
No, ma'am, we can't.
Where that's why we need to use pre-trained models. They will already use a pre-trained model by using basic images. For example, we need to classify only dog cat. We don't need other animals. What we do? We need to select some 1000 or 2000 dog and cat images. If we have that data, by using that data,
We'll
we'll
train the
fine
model.
tune existed pre-trained model. Yes, we'll fine tune existed pre-trained model to predict the whenever new data point comes, whether it is dog or cat, high accurately. That's what these are. Lot of techniques are there. You people need to analysis. That's it. And then coming, I already told you in PCA concept. We need to standardize before going to the PCA. We need to standardize data before going to the PCA. Let's see if we have the data. See, if we have the data, Y is the miles per gallon, and X1 is the weight of car, and X2 is the horsepower. If we have the different scales and different units, different measures, uh, if we apply PCA technique on this data, it won't give the good results. So before going to apply PCA method, we need to standardize this data to the some particular range, 0 to 1 or anything. Okay. Here there are the different types of methods, standardization methods. Here today I will explain two types. One is by using the range or Z value. Z value means standard by using standard deviation. You people already know about the x minus x mean by number of data points. Same formula here we will use. Here we will use x minus x mean by standard deviation. By using this formula, we'll standardize each and every data point in the independent variable. Okay. First, I calculated x mean. That means independent variables mean, standard deviation, and I provided formula for the standardization set. Okay. Then after, I provided this covariance value to the variable C. Here, I standardized the x value. How I standardize it? By calculating mean, standard deviation. First, I substituted this x mean and x standardization value to the standardization method. We got the standardized independent variables. Then after, I visualized what is the correlation between the each and every independent variable after standardization. Okay. But by seeing this plot to select some correlated values, it's not that much easy. Same again, there is a chance to the manual error. That's why I already told you eigenvalue. See, here I already told you which eigenvalue have the high information about the, let's here. The eigenvectors and eigenvalues of a matrix A defined to the non-zero x and lambda value respectively. Here, this is the eigenvalue. This is the eigenvalue. This is the direction. This is the direction. Eigenvalue means variation in the data. How do we select principal component value? Which independent variable have the high variation? We take that is the highest variation independent variable. We select it is the dominant principal component. If the variable which have the less variation, what we call it is the redundant principal component. Redundant means all points have the same information. There is no difference, there is no variance. That's why we call it as the redundant principal components. In PCA, principal components analysis, dimensionality reduction technique will select which variables have the high variation. Is it okay? Did you remember, Ranjit?
Ma'am?
Did you remember? We'll select always which independent variables have the high variation.
Ma'am,
That's
could you
what let's see. We have the x1, x2, two variables.
yeah.
We applied function x2 plus x1 to create the new variables. One is the x2 plus x1, another one is the x2 minus x1. These are the newly
Like the
created.
same as the outlier thing.
Yes, yes. For example, here we have the these are the some created new independent variables x1, x2. Here x2 variable doesn't have any variation. Here same information repeated in all records. But x1 have the lot of variation. Which variable will select to build the model? X1, right? Why? Because x1 have the high information. X2
Yeah.
doesn't have any information.
Yes,
Okay?
ma'am.
Yeah. So, but x1 have the two variables. Here we are not ignoring any variable. What is the input variables x1, x2? Here in x1, both are, we form one equation to combine the both independent variables. Okay. Same technique here we are use in eigenvector also. Here this is the eigenvalue. Which independent variable have the high eigenvalue? We called it as the dominant principal component. Means that variable have the high information.
Like we
Which
need to select,
variable have, sorry?
we need to select that high information value.
Yes,
Informative.
yes, high informative. That's why here I calculated eigenvalues for the each and every independent variable.
Like for the
Okay.
10. Ma'am.
Yeah, for the 30 variables,
Okay. Okay. Okay,
not
ma'am.
10, 30,
Okay.
30. These are the 30. I have calculated eigenvalue for the 30. Then after I have sorted, see, 0 to, I have sorted ascendingly. Then if you want to select only 50% or more, then we'll get two principal components. This is the one method. By using this standardization method, x equal to x minus, sorry, z equal to x minus x mean by standard deviation. But if you don't need to remember this formula every time, we have one other library, that is the scalar preprocessing. We have the standard scalar feature. By using this standard scalar feature, you can fit x value, x is the independent variables, to the standard scalar. It will give the automatically standardized output. Okay.
Yes, ma'am.
Here why I say I explain this equation means, first you need to know how they are calculated standardization,
Yes.
how they are standardizing input value. Here I am introducing the library which some are providing already standardized feature. This is the standard scalar feature. By using this one, if you can't, you can calculate like this. Okay. Then after SQL decomposition, import PCA. Here yeah, I I explained how to calculate eigenvalues, how to sort, and based on the uh, tolerance, how to select the principal components. Instead of that, if you want, you can directly use PCA feature from the SQL decomposition, from the SQL brackets decomposition function. Okay,
Ma'am,
it automatically provides
Okay.
eigenvalues. Okay,
Okay. If you directly use it.
yes. But here you don't know, here I said this is the 50%, but you don't know whether this 50% gives good accuracy or no, don't. You can use, this is the one way to select the principal components. Let's see total number of principal components 30. Why? Because we have the 30 independent variables. If client wants 90% accuracy, you can select only 5 or 6 principal components. Okay. If client wants 95%, this is the explained variance. This is the number of components. Okay. If you want to select more than 100 variance variables, you can select based on here. For example, uh, I'm okay with 85%. I'm okay with 85%. That's why how many variables are greater than 85%? 1, 2, 3, 4, 5, 6. 6 components are there which are have the information 85%. Okay. Let's see what is the accuracy. Explain variance. This is by using, see here I assigned PCA components which are highly more than 85%. Okay. Same components I am using here. Out of these, Here I said I have selected 6 principal components, right? But we don't know what are the independent variables we used to form that PCA, that principal component. Here is the that information. For example, in first component they used, for example, they use mean convey points, mean connectivity, worst convey points, worst perimeter. In second components, these are the some features. In third one, texture error, smoothness error, symmetry error, radius error. Let's see how PCA works. Every time errors, the information error, all type of errors gives the same information. That's why it created one combination by using only error
It
features.
created a separate thing based on the only errors
Yes,
on
separate
texture. Separate.
yes. Why? Because there is a chance to explain same variation. For example, these combination of these four features, it gives the high information about high variation. Maybe there is a chance to be a high variation. So this PCA package calculates like that. These are the some variables used for this to create 6 principal components. Okay. Some people will get some doubt here. In VIF we used 3 variables.
Yes, ma'am.
Okay, directly. So here also we are reducing components. Out of the 30, here we selected 3. It gives the 85%, 84% accuracy. Okay, instead of 3, here also we are reducing same thing. Here instead of 30, here we are selected only 6 components. But let's check the how the accuracy. It gives the 98% accuracy. Some people will get one doubt. Previously, I used 3 components. At that time, it gives 84% accuracy. Here, I used only 6 features, but it gives the 98%. There also, I eliminated some independent features.
Ma'am, but we are here
Independent,
standardizing, right?
yes, here standardized. Not only that, here mostly covered all 30 features information.
Okay, there we are covering only three things
Yes,
after pre-processing. Now we
yes,
are standardizing and pre-processing, and we are considering all the 30
yes.
so that it's
We
increased.
yes, we combined all information some 3 or 4 independent variables to the one independent variable by using some calculations. Here we are not ignoring any independent variable. We are providing same priority for the each and every independent variable. If we have the 30 independent variable, we are giving same priority for the all 30 independent variables. What we are doing, just we are combining some variables to create a variable which are having the high information. That's it. Here we are not eliminating, we are not ignoring any variable. That's the main reason. That's the uh, main difference between the feature selection and the dimensionality reduction. In feature selection, out of the 30 variable, we'll select some of the variables. We'll definitely are 100% ignoring some other variables. But in dimensionality reduction, here we won't ignore any variable, any independent variable. We'll give same priority for the all the independent variable. Just we'll combine those independent variables to create the new independent variable with a high variation. That's it. Due to that combination, here model accuracy will be increased. Okay. Okay,
Yes,
Ranjit. Is
yes, ma'am.
it?
Got it.
Yeah. So
It's a very like it's a good method, ma'am.
yeah, that's what.
Like because of standardization, they will be getting rid of all the errors. And
Yes.
again, if we are using all the 30 things, and we are increasing the
Accuracy.
accuracy. That's it, ma'am.
So, yeah, that's why I explained in 3 methods. If I
Yeah, ma'am.
directly explained the PCA, yes, by using PCA 99%, why won't you? You don't know difference between the feature selection and dimensionality reduction. That's why I included this method second also. So this is the difference between the feature selection. Maybe sometimes instead of dimensionality reduction, feature selection gives the good results, but it depends on the data and case scenario which model we are using.
Ma'am, I haven't got you, ma'am. I didn't
Yeah,
get you.
yeah, yeah. See, in this scenario, in this for this data set, dimensionality reduction gives the high accuracy compared to feature selection.
Ma'am,
Feature
feature
selection.
selection in the sense like
Here we
BIF.
selected 3 out of 30. We selected 3
Okay,
features.
okay. Done.
This is the feature selection.
This is dimensionality reduction. Third
This
one.
is the dimensionality reduction. Third one.
Yeah.
So, in for this case, for this data set, this feature selection not working. Dimensionality reduction works very well. But why? Because there is a chance. Here we have the lot of features, but very less records. See, 570 records only. Okay. We have the 570 records, 31 features. That's why here dimensionality reduction works. If we have the 30 features with 1 lakh records, maybe at that time, instead of dimensional reduction, this feature selection gives the more accuracy. There is a chance for that. Okay. But we need to check which method is useful to build model for this data set. Okay. Ranjit, what I'm saying is, in this scenario,
Ma'am,
you are able to yes, dimensionality reduction gives the high accuracy. Why? Because here we are not ignoring any independent variable. We are using all independent variables. Due to that reason, it gives the high accuracy. But don't fix like don't tune your
ma'am,
brain like,
we shouldn't fix blindly that. We need
yes,
to directly
this
go for
PCA will work for the all the data sets, all the models.
yeah. First,
Yeah.
we need to go for feature selection, then dimensional reduction.
Yes.
Okay, ma'am. Will be noted that.
Yeah. Next in next session, we'll explain about the regularization techniques also. Those will also useful to improve the model performance, model accuracy, everything. But we need to check everything while building model. We need to consider all scenarios while building model. Then only we are able to build good model. Why? Because by seeing case, by seeing data, we don't know which model and which pre-processing technique will be useful for this data. We need to analyze like this every time. Whenever we want to build good model. Okay. If there is one way to build good models, everyone will follow that way only. There is
Yes, ma'am.
no fixed way to build a good model.
Yes.
We need to analyze our data. We need to analyze our techniques or what is the concept we have. Then only we are able to build good models.
Yes.
Yeah. Uh, do you have any doubts?
No, ma'am.
Yes.
Okay, but like I have basically one doubt, ma'am, regarding that the codes which we are writing, which we are performing in the Jupyter, like basically how how you write those codes? Like basically we don't have a particular idea. We have idea
Okay.
on the
Okay.
concepts.
Okay. For example, let's take for you. I will build one with a notebook. This is okay. We'll create new Jupyter notebook. Okay. This is the new
Yes,
Jupyter notebook. I don't have any code. Which type of model do you want to build? Shall we
exactly.
build again logistic regression?
Not, ma'am, logistically, I'm okay with logistic regression. Now, PCA
PCA.
only.
Okay. Let's
Feature
take.
select you just do, ma'am.
Okay. PCA.
Ma'am, generally, like no one will be directly writing the code, or else they'll be directly copying it.
If someone able to write directly code, it's not good thing. Why? Because you don't waste time while to write the code. You just
Okay.
spend time on the to learn
Ma'am,
the new techniques, to learn the new uh, models, to learn the new concept, to learn the new features. In, for example, if Python previously they have the some libraries, but now they are providing more libraries, more new libraries. For example, in this scenario only, principal components. Here we have the I used one thing. Here we have the formula for the standardization. But shall we need everything to write this formula? they already provided standard scalar library for us.
Like
So
that, we can input any
yeah,
type of
we
library.
need, yes, we need to use new techniques which are they are providing to simplify our code. You need to write update on those libraries and those technologies, and that's it. You don't write same code for the everything every time. It's a waste of time. If we are able to do same thing within single line, why do we need to write these 4 lines
Yes,
here?
ma'am. Yeah,
Here these are these 3 lines and 1 line, 4 lines. Here I write within 2 lines.
yes, ma'am. Standards,
But
like
yes,
it's built formula which is there.
yes. So instead of write, not only that, let's assume uh, like a 10th class question and answer. Are you able to remember each and every line of code? Is
No,
it possible?
no, ma'am. That's the reason I'm asking.
Yeah, you don't. You will have. That's what. See, for the data science, so it's very easy to search code also. For example, let's see
Yes, ma'am.
principal component analysis, machine
Python,
learning.
machine learning, Python.
That's it. You have the geeks and some Stack Overflow. These will provide very simple information with in simple language also. Okay. Here you have the code with explanation. How to import libraries, how to import. They will provide some.
Like while facing different interviews, we might get some problem, right? Like they'll be allowing these things like for this copying. Like we are importing code from other sites, right? There might be any
See,
problem.
yeah. Just a minute. We'll say one thing. Coming to the interview, definitely we need to know about this. Some, for example, this is the PD read CSV. If you want to read anything in Jupyter Notebook, this is the library, PD, Pandas library. It will be useful to read Excel files, CSV files, PDF files, JSON files, everything.
Yeah, ma'am. It's like for pre-processing, we need to use pandas.
Yeah, well, that's why if they will ask mostly uh, how to how to write a list comprehension. List comprehension means I already told you. Just instead of for loop,
Yeah, ma'am.
for
One line.
I in X. This is the for loop.
Yeah,
You need to, if you want to use any if condition, if I is equal something,
yeah,
then you can give I. You can list I. If I is something, just then only you can sell. You can append this I value to the list.
yeah,
Okay. They will ask this type of questions. What is the difference between list? What is the difference between lift and dict? Lift, list means list of values.
yeah,
Okay. Escape. Yeah. So this is the, for example, list is equal list of values. Coming to the string, there is some difference between the string and list. String means just text, plain text. Okay.
yeah.
Dictionary means it have the keys and values. For example, this is the what is the basic Python. That's why I share you some link to getting the knowledge about the Python. For
Hmm.
example, here D is the key value. Key. And value for the D, this one is this one. You can give like this, whatever, how many keys you want. See if how can you use. Instead of writing entire value, you can use like this dictionary. Okay.
Yes. Basically, I know that, but how like how to write this complex type of codes? Basically, that's what my.
You will everything will be available in Google, and mostly in interview, mostly they will ask some libraries. For example, if you want to build logistic regression, how do you download that model? How do you use it? Just there is, for the every model there is only one code. For example, sklearn linear model import logistic regression, sklearn linear model import linear regression, sk ensemble model import random forest. Only single type of way we are using to load the model every time. Just for example, let's say here I imported standard scalar. That's why I give the standard scalar these open brackets.
Yes,
If you import a logistic regression, you can replace that logistic regression with a standard scalar. That's it. If you import a linear regression, you can import that one. For
yes.
example, yes. For PCA, you can import PCA of if is there any parameters. If you want, if
Got
those functions, yes, they will ask like this only, but they don't ask to write each and everything. For
yeah. Basically,
example,
my concern was like if they asked to write this complete thing, their time will be completely.
yes.
That's what.
For example, they will ask only for if you have the some unwanted data columns, date, time, some ID. They will ask how to drop those unwanted data. If you have the knowledge, you can directly use df dot. There is one function, drop
Drop,
function.
drop.
You want to drop. That's it. You can execute. It will automatically work.
Yes,
They will check whether you are able to. You are familiar or not for the Python packages.
yes.
Yeah.
Not for the
For example,
things.
yes, they will ask you have the some categorical data, but it have the some missing values. How do you know how many missing values do you have? How many? How do you feel? They will ask like that. First, you need to know about the yes. There is one function is null to check the whether it is there any missing values or not. If you have missing values, there is some other one. For example, I have the missing values on mean radius. There is one function missing values fill NA. Sorry, if you have the gap like this, that will not work. If you want to fill with 0, you can give directly 0. If you want fill with mean, you can directly give mean like this. Just they will check whether you know or don't know about this one.
Okay, ma'am. Like
Mm.
basic things they'll be asking.
Yeah, they will ask this. Everyone ask, do you know concepts or don't know? Will you checking it for, let's see, if they will ask how do you know whether data have the null values or not, write code. If you search Google search for the is null instead of writing is null, it's really bad. If you
Yes,
want to build, you can search Google search, it's very good. But to find the whether it is null values or not, to fill the null values, these are the common steps for the each, and whenever you try to build model, these are the common pre-process steps for the each and everything.
yes.
So you will use these same code for repeatedly. If you have the 1 year experience, you will use those same code minimum 30 to 50 times.
Okay,
Sometimes
ma'am.
there is 100 times the same checking is null values or not, how to fill values, how to standardize values, how to clean test. So you will
So that
automatically
we
you will know.
habituated to. Yeah,
Yes,
we'll be habituated.
yes, have it. So you don't search any Google. That's what.
Yes, ma'am.
For
Thank you, ma'am.
the if you want any one, you need to check like this only. For me also, I won't remember everything in my brain. Google
Yes.
have there is Google to help everything.
Thank you, ma'am.